I'm Matias Callara. I'm an industrial engineer with a master in optimization and a Ph.D. in informatics. And for over 10 years, I have been working at the intersection of machine learning, operational research, and decision theory. Currently, I work at Roche as a data scientist. Roche is a healthcare company where I support our leadership team on strategic and high-impact, high-value use cases. And I'm also an invited professor at Torcuato Di Tella University in Argentina. You can find me on LinkedIn by scanning the QR code there. Today we will be talking about forecasting and a new line of research based on the use of LLMs and their architectures. But before diving into the topic, I suggest to start with a concrete example to understand what we mean by forecasting and then explore why LLMs may be helpful. So let's imagine that we are the managers of a souvenir shop in Buenos Aires, and we are selling Argentinian jerseys. Every week, we need to decide how many units to stock for the upcoming weeks. This decision depends on the number of jerseys that the people will demand each week, which is uncertain. One way to think about this weekly uncertainty is to consider that there is an unknown probability distribution of different demand values. In this context, forecasting means to estimate some quantity related to this distribution. It could be the mean, it could be the median, it could be a quantile, or even the full probability distribution of the demand, in this case for the next week. But also, we could repeat the same process for the upcoming weeks. For example, here, we see this point estimate forecast for the 3 upcoming weeks. In the simplest setting, we could try to generate our forecast by leveraging the historical demand of the product. So, for instance, the demand of the previous n weeks. But most probably, we are not only selling Argentinian jerseys in our shop. We may need also to forecast other products. The historical data of other products may also even be helpful for us to forecast the demand of the jerseys. Other past information may also influence the demand of jerseys, like the result of previous matches, for instance. Similarly, upcoming matches or the weather forecast, for instance, can also be valuable information to generate our forecasts. In general, products like the jerseys may come in different sizes or types, and this static data about the product may also be relevant if we want to generate forecasts for them. But, for instance, if we need to forecast a new product with no historical data. While in this example, the granularity was, in this case, weekly, we may also need to create like a monthly forecast, or it's very easy to find, in general, different forecasting problems in which other granularities will be relevant. For instance, hourly, daily, monthly. So these and many more situations have been studied by the forecasting community for many years. And of course, different solutions have been also proposed. Unfortunately, effectively applying or combining these available methods is rather difficult and not straightforward. So it's easy to find very long discussions on social networks about, the many pitfalls in which even very seasoned researchers and practitioners still fall into. So wouldn't it be great if we could just simply provide our data to a system with less or no feature engineering at all, interact with that system in natural language, and generate and explore our forecast without the need of an expert to fine-tune or combine our models, automatically integrating all the information of the world the one that is provided by us, plus other data streams, as we mentioned, the weather, or even different modalities like video, speech, and many others, correct? So even furthermore, I think even leveraging the learnings done by other tasks or in other time series domain. So something like, as we see in this picture, it would be like taking our smartphone and asking to our bot, what would be the demand of share sales next week? And the bot will gently answer back the exact amount with almost no error. To answer that question, or to try to get to that point, it's when LLMs start to appear in the mind of many researchers around the world very recently. So if we think about LLMs, one first almost naive way of implementing a forecasting system would be just to take our historical data, construct a prompt, the phrase, like in this case, the temperature were the values in degrees for the past 4 days, what will be the temperature tomorrow? And basically, by asking this question to the LLM, get an answer. This is basically what the researchers that proposed the model that was named PromptCast did. And they actually trained and tested this model with data from different domains like weather, energy consumption, and human mobility. But unfortunately, this approach requires us to create a prompt that depends on the data or a specific forecast that we want to generate, correct? We see here it's basically linking back to the temperature, and you need to specify that this was 4 days, and then you would even need to say how many days in the future you want to forecast. So this becomes rather difficult in this case. And we also, in this paper, see that they actually propose to fine-tune the LLM. If we think, about the LLM, actually, we are feeding a prompt in a set of characters. So this phrase, in this case, the dog jumped up on the bed. And then we get out of it different samples, because it basically models a probability distribution over the next tokens. But underlying those tokens, there are numbers, actually, indexes of the tokens. And if we look at it in this kind of way, basically what we see is a forecasting problem. We are inputting numbers and getting numbers out of the model with a certain probability, as we described it at the beginning. So with that in mind, the team that proposed this paper about a model that was named LLM Time, basically what they suggested is, instead of preparing this handcrafted prompt, you can just simply input the numbers and see the values that you get out of the model, or in this case, the LLM, without pre-training it or fine-tuning it. And this is how they basically observe that the accuracy of that forecaster was comparable to other models that are well known by the forecasting community. Furthermore, they also explore the fact that when the model perform better in these tasks or evaluations that are related to a measure of intelligence, the error was also improving. So the more intelligent the model was, the better it performs in terms of forecasting accuracy. But so far, actually, we discussed about models, LLMs in this case, pre-trained on text. When we think about foundational models, we think about neural networks that are trained on large amounts of diverse data and then applied to a broad range of tasks. This is why we consider LLMs foundation models, because we can use them for different tasks. So a natural next question would be to think if we can develop what we could call a foundation model for time series. So instead of training on text, we can maybe train on time series and see if we can not only just solve the forecasting problem or task, but also, for instance, apply it to classification, imputation, or anomaly detection in time series. This is essentially what the Nixla team did when they trained the TimeGPT-1 model on over 100 billion data points and launched it in July 2023. This model, unfortunately, was not, and it is actually not openly accessible. It's a commercial model, and at the time the paper basically was released, the architecture and the weights were not openly available. Although the benchmark dataset that was used was not initially shared, later they published a fully reproducible benchmark. In this original paper, they shared a set of results comparing basically the model with other well-known models for different granularities of the data. And it showed also a good performance. Just in a period of 6 months after the release of TimeGPT, we had really many different companies and organizations releasing also their own foundation models. And for instance, 7 days after TimeGPT-1 article was submitted to the archive, LagLlama, from a very diverse group of researchers from Morgan Stanley, ServiceNow, Mila, and McGill University, they released a model named LagLlama. Then Google with TimeFM followed. After that, we see Moray with from Salesforce, and also just days after, we have Kronos from Amazon. Then at that point, finally, Nixla also published this fully reproducible benchmark, now based on 50,000 time series. And it looked very promising for TimeGPT. Here we see, just to have an idea, we don't need to pay attention now on numbers, but the idea is that this TimeGPT model was followed closely by TimesFM. But also thanks to this benchmark, the Kronos team found out that there was a bug on their implementation, on their code, and they fixed it. And I believe that these results are actually previous to that bug fix, which eventually, I understand, improved the performance also of the Kronos models, bringing it closer to the other ones. So far, we have been focusing on this forecasting problem, but we said that foundation models are supposed to be general purpose. And this is, I guess, when it is worth to mention Moment, which is actually a family of open time series foundation models. And in this case, we see that basically they not only compare on forecasting problems, but also on, for instance, classification and imputation. And up to now, all the models that I described are rather large in size, in the number of parameters, and they require considerable resources. So it's costly to run these models, or actually to pay for access to the endpoints. So we had another model or even set of models coming up from IBM research, in this case, tiny time mixers, which are basically also trying to decrease the size of the models and make them more accessible, even up to the point of being possible to run these models on CPUs. So in this session, I tried to summarize some of the key initial results that I found very interesting to share with you. And, I also wanted to be clear that maybe not all is sunshine and rainbows. We see, for instance, that so far, unlike advancements, that we have observed before in computer vision task or NLP, in this case, with forecasting foundation models, we don't see yet, at least, these breakthroughs with significant outperformance of the methods, correct? So this is already an important point to keep in mind. But even if we look in detail to each of these models that I share with you and even others, we may observe that depending on the model, there are different constraints and limitations. And just to name one for you to have an idea, we can mention the limitation in Chronos due to the quantization here. What we do is that we can only predict a set of tokens for the forecast. And if the data really change in scale very aggressively with respect, to the data that was fed in the prompt, we may have problems, and it may actually lay out of this set of tokens that we define. Apart from the problems with the models, we actually have a limitation here in the data that is available to train these foundation models. Open time series data sets are relatively scarce when we compare, for instance, in the case of images, and even finding effective incentives for companies and organizations to share their data, it's also very challenging. We also have a benchmarking challenge because it's also difficult to establish a data set that it can be solely used for benchmarking purposes, and also to guarantee that any of these models is using it for training. So leakage from this data set, it's a risk. We also have actually a significant or at least a part of the community that remains skeptical, and even we had some papers refuting the results of previous researchers. So I think that it's fair to say that this desiderata that I described at the beginning, it's still, we are not there. We didn't achieve and manage to have all these wishes. But I think that to conclude, there is a phrase that a colleague of mine actually brought to my attention very recently, which I believe it very nicely summarized my feeling regarding this topic at the moment. So this is a phrase from Thomas Mikolov, and as he said, the real lesson is that whatever works the best today is beatable by something that we have to still invent. And to invent it, we actually have to try to work on something new. Thank you so much.